Hello everybody, this is Miss Richardson. Today we will be talking about how we can plug polynomials into functions. For those of you who are wondering what I mean by that, let me just give us a little example. Let's say that we have a function, and this function is named f of x and equals 2x squared. Let's say that I want to find f of a plus b, given that f of x is equal to this function right here. So we're going to go about this by color coding. So f of a plus b, let's make a plus b red so we can kind of keep track of wherever it needs to go. I know that if I'm plugging a plus b into f, well, that means that wherever I see my input x inside of my function f of x here, then I'm just going to replace that input x with a plus b, because this is pretty much like saying let x equal a plus b. And doing that, we're going to replace everywhere we see an x in this function, we're going to replace it with a plus b. So my f of x turned into f of a plus b. Next it says equals 2x squared, so 2 times x squared. But wait, x is a plus b, so it's going to be 2 times a plus b squared. And I'll continue my color coding just for consistency. Plus 1. So just take a second to look at how this here is exactly the same as this here, given that x and a plus b switch places because they're equal to one another. We substituted a plus b in wherever we saw an x. Ultimately, this is my function. This is the function we're looking for, but of course, in math, we always want to simplify. So let's go and simplify. I'll use my order of operations. We know the first thing we need to do is apply this exponent here. And so a plus b squared, for those of us who just need a little reminder, we can go over here and do some scratch work. A plus b squared is the same as a plus b times a plus b, and I always make sure to write it out like this because I see all the time students forgetting to distribute when they do this. I constantly see the mistake made where students will think a plus b squared is literally just a squared plus b squared, and that's not at all what it equals. We have to remember that we have to distribute, and when we distribute, we're going to get 3 terms. So first I'll distribute my a times my a. When I do that, of course, a times a is a squared. And then I'll do my a times my b. Of course, a times b is just ab. Now I have a b times an a, which is, again, just ab. Last but not least, I have my b times my b, which is just b to the second power. We always want to check to see if we have like terms, and I see that I do have like terms right here. I have one ab here and another ab here. Together, that's 2 ab's that I have. Those are the only like terms, so everything else, if it didn't change, it's going to stay the same. I still have my a squared. We know these 2 ab's came together to make literally 2 ab's. And then I have my b squared term. So that's just giving me this part of the problem. I know that wherever I see an a plus b squared, it's equal to a squared plus 2ab plus b squared. So let's go put that back into this problem that we're working on. So we needed to distribute to apply that power there, and we did that, and we found out that this piece here equals that there. So let's replace it. I'm just going to rewrite the whole problem. I'm going to start by writing the 2. I have my parenthesis right after the 2. Inside I have a plus b squared. Well, what is a plus b squared? Now we know that it's just a squared plus 2ab plus b squared. All of that there, plus the 1 that's outside. So this part here turned into all of this here after squaring it. And then we want to check to see, like, are there any other like terms we can combine? Still applying my order of operations, I see that there's multiplication that needs to be done. This 2 here now needs to be distributed into every single term inside of this group, 1 term at a time. So first I'll do 2 times a squared, which is, of course, 2a squared. And then we'll do 2 times 2ab, which is, of course, 4ab. Lastly, we'll do 2 times b squared, which is, of course, 2b squared. And then we just have this 1 that's been hanging out there the whole time, minding its business, hasn't done anything to change itself, and so it stays the same. But there we have it, the simplified form of our function f of a plus b given a plus b and the function f of x up there.